So we will start with this keyword search stuff. Okay. So in the keyword search, you can open up the Colab notebook. So there are two important things that we have learned during the last session. One is tokenization, and the second one is embedding, right? First one is tokenization, second one is embedding. So that's what we learned. And after that, we have learned how the reviews, movie reviews, sentiment analysis is done using the data action. So the model to analyze the movie reviews, and based on the movie reviews, the model will be able to predict whether that is a positive movie review or negative movie review. So this keyword search is another NLP technique. So I just want to highlight that part before going to today's lecture session, because we are going to do today 4 tutorials, very small one. First one is keyword search. So how it works in the natural language process. Second one is semantic search. So what is the difference between the keyword search and semantic search? After that, we are going to build up a chatbot based on the keywords. And we are going to check what are the negative aspects of that chatbot and the positive aspects of that kind of chatbot. Then we are going to move into another chatbot, which is going to be semantic based chatbot. So we will see how the semantic based chatbot overcame the negative issues in the keyword based chatbot, right? So still we are not going to connect to LLMs, so that we will do next time. But I will tell you what happens in the chatbot that we have built up for this AI program, right? So the first thing is when you enter a text, like text, right? It gets tokenization, right? Tokenization means break the text into individual bits, right? So welcome to AI means welcome is one word, to is one word, AI is another word, program is another word. So that is called as tokenization, right? And providing embedding means giving certain numbers to each word. So we have constructed an embedding mechanism during last lectures. So that is a very basic part, right? Later on, we also have seen an embedding mechanism called BERT, right? BERT model. So we send the text through the BERT model. What it does is it's tokenized first. After that, for each word, it gives an embedding number. But when you take the embeddings number for the one word in BERT, it has close to 125 embeddings. We consider not only the word, but also the meaning, where its placement, everything, right? So in that case, that embedding is more valuable than the embeddings mechanism that we have built up just with 3 numbers. So what we have built up is last time giving a number. Okay, is the word start with a capital letter? Second, is the word how many letters are in the word? Third, what is the position of this word in the sentence? So this is how we have given the token. But let's say there are same words repeating again and again. In that case, what happened? It gave a different number for the same word, because is the letter starts with capital, how many letters are in the word, and the other one is which position the token is. So in that case, welcome to the AI program. AI program is designed for. So now AI repeated 2 times. The first AI will be given a different embeddings number, and the second AI will be given a different embedding. So that is not good, because we are going to do these keyword search and semantic search and everything using this embedding, right? So all the chatbots in the backend, we are going to use the embedding. So if the same word have different embeddings, it's not good. So what we have done, okay. So before giving a token, we looped using a for loop, right? In the for loop, we check whether if the same word existed earlier. If it existed earlier, then the earlier number was given. If this is AII, again AII comes, then its same number is given to that. So we have avoided the thing. But when we use the BERT model, we also have observed for the same word, different embeddings are given, right? The reason the bird does not only check the position and the stuff, it also checks the meaning, where the meaning of that thing, the strength of that word in that sentence. So there are multiple embeddings. Embedding is what? So similar to the face embeddings, voice embeddings that we have done for the attention system, right? So we take a face, take an image, to send through an OpenCV platform, it detects certain positions. Those are the embeddings. So for the voice embeddings, we send the voice, it detected certain patterns and frequency and certain parameters from voice. It created 256 parameter embedding vector. So then when a person talk, we record this, extract the embeddings and check which is matching with the existing data. Right? So that is embeddings. Similarly, we are going to give embeddings for each word. So first tokenize it, that means separate each word into including the comma, full stop, question marks, and everything. And giving embeddings means we are giving individual number for each word. Right? So this is the thing that we have learned during the last lectures. So today we are going to learn 4 small tutorials to understand how the chatbots were initiated. The first one is keyword extraction process in Python with natural language processing. So what is keyword extraction? So for example, where it's used in Google, right? In Google. So when you start to type for the searching something, it looks for the keyword. It looks for the keyword and recommend. If you go to YouTube, type something, it recommends a lot of stuff. For example, if I go to YouTube here, okay. So if I want to say AI, see, Ola recommended over here. This is keyword search. Wherever AI is there, it's going to recommend that search thing. So these are keyword algorithms. So how it happens? And also, one more thing I have told you last time, what is the meaning of AI, right? What is the meaning of AI? Okay, and a question mark. And I'm going to go back again to another thing. What meaning AI question mark? Okay, so we'll search the things. Artificial intelligence, AI dictionary. What is artificial intelligence? What is artificial intelligence? Here we will go to that. Artificial intelligence. What is artificial intelligence? Same links are coming up. But I typed here, what is the meaning of AI? Right? Here, what meaning AI? So what is happening? Basically, when we are searching for certain information in this stuff, this is the are does not going to make any sense. So those are called as stop words, right? Even in the movie review during last time, we removed the stop words, right? Because it doesn't make any meaning over there. It just stop words. So to review our movie and get the feedback back and see whether it's a good review or a bad review, then we remove the stop words and we search for the meaning, right? So then we identify that's the thing. So the same thing, even the Google search, it doesn't matter. While searching, it's remove the is the stop words and only look for the keywords and identify which matches, right? So that's the thing. Even in Netflix, if you go and search a movie, keyword matches, right? So there are a lot of things. So even, yeah, so there are a lot of example I can pull up for keyword matches. So it's an old technique. Even the Google does not came up with this new thing, right? It was there since 2000. When it's launched, Google, it was there already, 2002, 3, I don't know, even Edge, Microsoft Edge, right? So it called Internet Explorer at that time. So it also had that feature, keyword search. So similarly, the keyword search is used in many other AI NLP applications as well, right? So here, whatever I mentioned over here, you can do that. It's mentioned. The Space is one of the library we have learned during last lectures for what? Named entity recognition, right? Named entity recognition. So we have extracted certain names entities from a text and we found out certain text were missing, right? Detected in a different context. Later on, what we have done, We have trained the Spacey model to detect our custom named entity recognition model. For example, if you are saying names, Sri Lankan names are totally different than the American names of a person. So the Spacey is designed for John, Michael, Phillips, like that. It will not be able to detect Jayasuri as a name sometimes. So if you want to detect Sinhala names or Tamil names, we have to have a Spacey model custom trained to detect the named entities, right? So we are doing a project in another place where I do some consultancy. They are working with airlines. So certain airline names, credit card numbers, and date of birth, travel destination, place to place, where he is going, all the informations are entered. So when they are using the chat GPT, it's a huge text. Let's say they like had an issue in the code. So what they do is they copy, paste the code in the chat GPT and they ask question and it's all copy paste. But what is happening now is when they copy paste those information, the data of that person is exposed to the GPT. Next time, when they are training the model, they are going to take that data. So that means his credit card number is there, his date of birth is there, his contact details are there, everything ChatGPT knows now. For example, I'll go to ChatGPT. Give me a second. This is crazy these days, right? You can, if you are using ChatGPT, right? I'll go and I'm going to ask here, okay, who am I? See? You are someone who works with machine learning, particularly in application like text-to-speech, speech recognition challenges, because I was using this to create the tutorials, right? So it knows that. So what's my name? Mhm. Okay. Oh my goodness. So you work with AI, machine learning thing, text to speech, blah blah things. You are involved various projects, including working with Teramark platform, developing proposal for Silverchef, evaluating LLMs, large language model for different applications. Crazy, right? So because how it knows is because I search for this thing, right? I prepared a report for Teramark platform using ChatGPT. So it knows it's what I'm working on. So that means you are giving all the data. So you have strong and research background, including collaboration with expert like you also guide students. It's understood in a different way. My name is Logishan, but it says you collaborate with Dr. Logishan because it identifies the names several times. My name over there. Use Google Colab for model training with different data, blah 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 thing. Role you are the head of the department, oversee various research and development. No, I developed certain letters for head of the department on behalf of him. So he thought I am the head of the department, right? So these are the thing issues. You are exposing the whole detail to the GPT when you are using the GPT. So this is okay for us. Who cares? My data is going there. Credit card goes, it's a very big concern, but I never put the credit card by conscious. But a person credit card information is going to the GPT. In future, I can come and ask, what is his credit card number? Done. Right? It's going to expose. So it's not good. So what they want to do is they want to create a model which it detects the name, credit card information, contact details, date of birth, and other sensitive information of the customer and hide them before we send it to the GPT. So now what we have built is we selected the Spacey model. Most of the passengers who travels from place to place are Mexicans in that airlines, right? It's a Mexican airline. So we got Mexican names specifically trained for Mexican names, Mexican credit card type numbers, and Gmail's account. That will be detected easily because that at symbol is enough to detect the Gmail. And the other contact details, Mexican numbers, we collected thousands of data. We trained the Spacey model to identify that certain important information. So once it identifies, what it will do is if the name coming up De Souza or something from Mexico, it will be masked as name. I am in bracket name, right? And my credit card number is in the bracket credit card number. It will not expose it to the ChatGPT. It will mask. So then it will put it to the ChatGPT. So ChatGPT know there is a name, there is a credit card number, there should be a something like that. So it will generate the response based on that hidden information. And it will give back the information to you again with the mask. Credit card number will not be exposed to you. So then what we take is we get the response and we know what we have replaced, right? So it will be replaced again with the correct information shown to the customer. So there is an intermediate backend is working. So when they enter the chat into ChatGPT, or they have created a front end. So in the backend, it will be masked, sent to ChatGPT, the response will be gathered and demask it using the correct information, show it to the client. So in that case, they don't want to worry about anything by using these GPTs. And GPT started to face around 2000, I think, like cases regarding the data breaches because they have used internet data, they scraped the data, and they have used for their business. Scraping the data was okay earlier, but nowadays it's become as illegal. Recently, LinkedIn has sued a company for multi-million dollars penalty just to they have used and scraped the LinkedIn data to do some other business purposes. It's completely illegal, right? Recent day before yesterday or something, LinkedIn. So data scraping is very bad these days. So how the GPT is trained on? Completely on data scraping. So they are having a lot of issues. So you can see how it knows my information, right? Simple. See, if you type who is Dr. Logician, can you type in your GPT and see? It might give you because it knows already who am I, right? So that's not good. So that is not good at all. So that's the thing. So there will be no privacy. So these are some critical issues going on in the current world. So how we are going to do that using the NLP is the task. So one thing, we hide the information using the NER. So that is the SPACY model that we have used. The SPACY is a kind of model which is a very strong for NLP tasks. So named entity recognition, keyword search, blah stuff, right? So there are a lot of things the SPACY model is used for. So here we are going to use the SPACY to detect the keywords, right? Detect the keywords. So what we are going to install is the first NLP, Natural Language Toolkit, SPACY, and we will download the SPACY small version. SM means small. LG means large. What it's saying about me? Can you read it? Saying some crazy shit. Yeah, see, it knows everything. So why? Because I prepare a certain proposal, introduction, everything using GPT. No wonder it knows because my data is trained. I'm using from 3.5. Now 3.5 is not there. 4a mini is there, right? 4o mini means they retrain the data. So my data is got trained again. So it's not good for a company. So if the Coca-Cola start to use that, the recipe will be leaked, right? So simple. So it's very bad these days because they are breaching. So many people have filed complaint against GPT thing, but they can't say because it's free. You are using it for free, then we will use it. So I saw a post in Facebook. If you are not paying for a product, you are the product, right? If you are not paying for a product, you are the product. For example, Facebook, you are the product. They are marketing. They make you buy things. My father started to order a lot of stuff in Facebook, right? He started to use Facebook, buying stuff in network. A lot of advertisements are posted. So when I talk about, I'm thinking about building a house yesterday, last night, today I saw back-to-back advertisement in Facebook. Sri Lankan construction companies. I can show you, pull up my Facebook and show you. A lot of advertisement. Last night I just talked to my friend thinking about starting a home or something, building a home. That's all I did. Google heard, transferred to Facebook. Facebook is sending me recommendations, right? So that's how. So I'm the product of Facebook. GPT, I'm the product of GPT. So nothing is free. right? So if you are using it for free, there is some issues, right? So now we will do the keyword search. So what do you think based on these text tokenization embeddings, how the keyword is searched? First of all, we are breaking it in the tokens, right? So individual words. So when you search for a keyword, it's save it as a tuple or tuples, right? We learned in second lectures or something, dictionary, tuples and stuff, right? Lists. So it save it as a tuple. So then when you search for the keywords, it goes through the tuples and identified whether is there any tokens exist with that keyword name. That's all, nothing else. So it's only consider the tokens, right? So let's install first this installing the necessary dependencies. We are installing the Enco Web. SM means small, LG means large, medium means MD, I believe. Yeah. So there are three models. Large means it's little heavy. It's trained on millions of data. Small means less data. So that kind of. So small is enough for our keyword search. That is more than enough. Yeah. Let's install it. So we have used the Punkt, PUNKT tool for tokenization during the last lectures also, which is a natural language toolkit, data for tokenization. Here also we will use that same NLTK PUNKT toolkit for tokenization. There are a lot of ways of tokenization. Even we have built our own custom tokenization. PUNKT tool has its own embedding system, like tokenization way, how it's create the token. So now we are going to do it, and we are going to load the Spatie model into our platform because we have downloaded. This is the Spatie model, which is small. So what are the Spatie models available? Enco Web Small, Enco Web Medium, Enco Web Large. Three Spatie models are there. So we are going to load the small one. At the same time, we are going to use the PUNKT for the tokenization. So let's download that and load the Spatie model into our system. Okay, find. So then we have to define the function. So one is pre-processing the text and the second one is searching the keywords. So what we do is first we have to tokenize whatever the text is, right? You are inputting a paragraph. We have to break that paragraph word by word, even the punctuation, comma, full stop, question marks, exclamation marks, everything need to be broken. So the tokens, word tokenize, the same library that we have used in the last lectures, and we are going to return the tokens. So this is the function. You remember something like this, right? We have learned in second lecture or third lecture, defining a function, right? So here, the search keyword function. So I'm going to take the tokens input because it's going to return the tokens. I'm going to take the tokens as consideration, and the keywords are going to go into the tokens. So found keywords, keyword for keyword in keywords, if keyword in tokens. That means what? I'm going to go through for loop, right? For keyword in keywords, if the keyword in token. So it's a for loop going through that list and identify these tokens and get it back. If is it found, it will return the found keywords. That's all, simple. So let's say this is the text that I'm going to use. Natural language processing is a field of artificial intelligence that focuses on interaction between computers and humans through natural language. The ultimate objective of NLP is to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. NLP encompasses a range of tasks, including text classification, sentiment analysis, named entity recognition, and machine translation. So this is the text. Let me load the text. Did I play it? Yeah. So after that, the keywords that I'm going to search now is natural language processing, AI, text analysis, AI. So I'm going to search these keywords and see whether these are existed in the text that I have provided as an example. So the tokens, what is going to happen as pre-processed text. It's calling the function which we have defined over here. Pre-processed text. So I have defined the text here. So pre-processed text mean it is going to be tokenized, right? And it's going to return the tokens of this sentence. And found keywords, what is going to happen? Search keywords, token keywords. So it's going to go search keywords, token keywords. I'm calling that function again. So I'm going to print the tokens and print the found keywords over here. So once you play it, you can see the tokens. If you go back, natural language processing. Here N capital, L capital, P capital. But here if you see N, L, P, all small. So it's only tokenized based on small letters. Last time also we have discussed it because it doesn't make any sense to have a capital letter. But embeddings, it may consider the capital letter, right? Based on the different embedding techniques. So here you can say natural language processing and comma. Comma is taken as a word, NLP, and a bracket, another bracket. You get it, right? What are those stuff? And is a field of artificial intelligence that focus on the individual words. So after that, what happens? These are the keywords that I am searching for. First, it take the natural and go through this list and see whether the natural is existed, right? If it is existed, then print the natural over here. Go language. Go through this language, search for the language keyword. If it is there, it printed over here. Processing, it goes through this, identify the processing is existed, and it's print over here. AI, it goes through that, it couldn't find the AI. It couldn't find the AI because it's named as artificial intelligence. So it couldn't find AI, so there is no AI in the found keywords. And the text, it go through the system, find out the text, printed over here. Analysis, it found out the word analysis and we printed over here. AII, it couldn't find it in the text, it didn't print it over here. So we are searching the keywords, right? And we are printing it over there. So also the Spatie had a good ability to detect the keywords, whether it's there or not, because we are using the search keyword token using these thing. And the Spatie have another ability to identify the entities. If you go there, you can see natural language processing, NLP, is detected as work of art. Again, NLP is detected as organization. Another NLP is detected as organization. So this is named entity recognition, right? That we have learned during the thing, but it's not good because we are dealing with the small model. If you put the LG, maybe we have to install the LG here in that case. Yeah, I have to install the LG. Then if you change it, it may get improved. So that's how the keyword search is done. Even in Google, it's already tokenized. So it's go through the tokenization. If it's there, it just pull up. Even YouTube, TikTok, whatever the thing, the recommendation system based on the keyword is done in this manner. Okay, right. So now, do you think you can build up a chatbot based on this keyword search? It's a chatbot. You want to build it for your organization. Do you think you can use this keyword search mechanism to build a chatbot? So I define the questions because let's say SIST want to build a chatbot for their website. They know what are the typical questions asked by the students, right? They call when the course is going to start. How can I pay the money? Can I pay in installments? Or where is it located? All the classes are on Saturday, Sunday. What is the timetable? So these are the general questions students ask the customer care, right? Even the parents call and they ask about the degree, whether it's affiliated or not. So a set of questions the customer care center knows. The call center knows what are the questions. So I define those questions. Question, answer, question, answer, question, answer. Then if a person comes and asks, what is the course fees of this course? Then it identify the keywords, course fees of AII program, what, everything, it's identify the keyword. And it find out which question matches the maximum number of keywords. then it prints the answer, right? It prints the answer. Can be done, right? Can be simply done. So let's now go back to these chatbots and it's hidden from student. Second, enable edit. To not type from student. Okay. Now you can see, why is that? Oh, okay. Now you can see, reload the thing. You can see two things, keyword search based chatbot, right? Here. So you can click it open. Okay. Then there will be another Google Colab will be open. So now we have learned how to build up a keyword search mechanism. We are going to use that to build a chatbot. So this was the earlier days chatbot. Earlier days. So when a person want a chatbot, this is how they have created. For example, earlier days, the Taj Hotel has the chatbot in their website. Even before the ChatGPT came, they had a chatbot in the website. You can ask certain questions, right? Those are keyword search thing. But the problem is, you will see what is the issue with the keyword search chatbot with the chatbot that we have in the AII program, right? Over the chatbot, we have built a chatbot for ESOP right now. So let me load that one also. Maybe ESOP Metro Campus. Go there. It has more than 100 sublinks for each courses, each affiliated degrees and everything. It'll take a while and it will load the chatbot over here. Once it loaded, we can see. So this is a different chatbot. So we are going to learn that this kind of chatbot next week. Okay. Take a lot of time. Here we go. So this is chatbot. So you can just type your name, blah blah thing, logi, phone number 0705364, email, affiliation at zero. Okay. So now I go there. So it start to chat with me. It's an AI based chatbot. I don't know why it's slow a little bit these days. I need to check with them. Ah, cool. Yeah. You can try it out. It might be faster in your thing because I'm loading the old one still. Hi, I'm Freddy, Ease of AI counselor. How can I help you? I want to know few details about the HND program. Okay. So it's going to go through the thing. Not available me at the moment. Okay. What about the HND computer? Let's see. It's down, I think. Second. Okay. Maybe okay.
So these are not keyword-based chatbot. It works in a different way, right? Because see, for the computer engineering degrees of Metro Campus, blah, blah, blah thing, it'll be able to pull out the information and give you. Okay. Okay. What the HND courses you have? Maybe. So what it has in the backend is the whole database of this website, right? We scrape the information with the with the consent of eSoft because we have built it for them. So it has the whole information which is mentioned in the website as the input to this chat. So what it does is it does not, I think it's not available right now in the eSoft Metro campus. Maybe it's not available, I'm not sure. So then it goes through the database and it find out the answer. But the thing is, it's not keyword based thing. So let's build up a keyword based chatbot. So if you ask HND computer something, then it should go through that whole text. In the keyword based chatbot, the thing is, we have to define the question and we have to provide the answer, right? So it's first when you enter the keywords, it's go for the search in the questions, identify the maximum matches in the keyword in the question, and it pull out and display the answer for you. That's all. So whatever the way you ask, the same answer is going to be displayed. But here in the eSoft thing that I have shown you, it's going to be completely different. Okay. So now there are, if you see, one thing is menu button based chatbot. Second one is keyword recognition. Third one is the contextual. So eSoft bot is contextual bot. Keyword now we will build it. Menu button means, so you go to a place, okay. If you go to a customer care dialog, you have to click multiple option to go to the final check. So that is kind of menu button based. So there are predefined problems. You click, go. And finally, it will maybe route to a customer care agent or something. But if you disconnected in the call in the middle, again, you have to start from the beginning. So that is kind of menu based chatbot. Keyword means you enter based on the keyword, it's going to choose. So that's what that we are going to do. Contextual also, we will do it to a certain manner, right? So the menu based have a lot of issues, pros and cons if you have used it. And there are things, okay, register now, like that you click a certain things. After that, you have to go to the next thing. It will give couple of options. You have to click a one, then it will couple of options, click a one, like that, like that. You will be able to troubleshoot. Keyword recognition based on the keyword, and it's going to pull out the answer, right? And the other one, contextual, we will do it in this class after this lesson, right? Okay. So now we will import the required libraries over here. Import RE and import random. So these are already installed in the Python as a default. So we don't want to install it again. We can directly download. So we are going to define the rules now. Okay, a simple rules. So we are going to define it as this one, greeting. So the greeting, hello, how can I assist you today? Hi there, what can I help you? How can I do for you? How can I help you? So these are three different greetings I have mentioned. So the chatbot will be able to pull out one of these. If I say, hey there, it will pull out and show it in the text. Goodbye. So that is good. Goodbye. Have a great day. See you later. Take care. So these three kind of things I have defined as goodbye. So default, I have mentioned, sorry, I didn't understand that. Can you please rephrase? I'm not sure how to respond to that. So these are three responses I put to the chatbot. So if you want something, you can add more as defaults. So now defining simple rules means we have to tell the chatbot, right? When the hello is mentioned, hi is mentioned, hey is mentioned, right? If that's the user input, you have to go to the greeting and randomly choose one of these things and display, right? So if is it bye, goodbye, see you, something like that, you have seen it, you have to go to the greetings and you have to go and say the goodbye. Go to the go to the goodbye and you have to pull randomly one thing and display it over there. Similarly, the last one, if anything else is not there, if these two are not there, then you go to the default, pull one of these things and display to the chat. So that's the rule-based chatbot I am going to build. So I have defined the rules, greeting, goodbye, default only 3. So I have defined how to do that stuff. If anything related to this is asked, go to the greetings. If anything related to some word like this, go to the thing. If you find out something like anything other than that, go to the default. So I have defined that thing. So first we will define the rules by running this. And after that, I'm going to go and define the simple rules, how to look for. Then defining the chat. It's a function of chat. Okay, chatbot will give a print at the beginning. After that, user input you are going to enter. Then after that, it's going to give the certain responses. Now let's chat with the chatbot that we have created. Okay. So now you can see, hi, I'm your chatbot. Type exit to enter the chat. Right. So that's the thing. So I'm going to say, hi there. So now what is going to there is, if I type hi there, it goes to the rules. Hello, hi, hey. It's find out hi. So if is it found out hi, it's going to go to the greeting. It goes to the greeting and finds out one thing. Hey, how can I assist you today? Is that the one that's printed me? Hey, how can I help you? So that is another response from here. Hey, how can I help you? It's printed over there. I'm going to type, hey, just hey. Hello, how can I assist you today? What is again happening? It found out hey, then it goes there, greetings, and it randomly found, hello, how can I assist you today? Right? If you enter another one, it's going to take that as well. So then I'm going to say, hello, good morning. Okay. Then it's going to go, hello, how can I assist? It's randomly selecting the answer. So in different way, how can we greet? Rather than saying hello, hi, hey, I can greet good morning, right? Just I'm going to say good morning. Can you please rephrase? What is happening now? Because in the rules, I didn't say good morning is a greeting, right? I just define hello, hi, hey. These are the greetings. If these greetings entered by the user, you find out that keyword, go to the greeting. So it was earlier going to this thing. Now, I just say good morning. So here, there is no good morning. It say bye, goodbye, or see you. These keywords finding, it will go to the goodbye session. So goodbye session here. But other than these two, it's going to go to the default. So when I say good morning, it go to the default and say, can you please rephrase it? Right? So this is a wrong issue. So these are the issues in the keyword-based chatbots. So I'm going to say another thing, good evening. Let's see how it's going. I'm not sure how to respond to that because what is happening? We have defined the rules again. It's going to the default and printing it one, right? So anybody can build up a chatbot using the keyword search, but it's going to be very tricky. It's not going to answer your question. So you have to use the exact keyword that you are looking for. Otherwise, what is going to say? It's not there. It's not there. So that's the issue. So we will exit now. Oh, goodbye. Goodbye. Okay, see you. See you. Then what is going to happen? It knows I have defined the CU as a rule here. If the CU is there, it's going to go to goodbye and see you later. Oh, goodbye. Have a great day. Oh, take care. Whatever the message is going to be pulled out and displayed over here. That's all. Right now, I'm going to exit it. Right? Goodbye. Chat is over. Good. So let's do it for a little bigger rule data sets. Okay. So I'm going to build up a chatbot to give a knowledge to the customers about AI. So what I have done, definition, types, application, figures, default. Okay. So I have created here like simple rules, greetings, goodbye default. I have created multiple things. So in the definition, what is artificial intelligence? Artificial intelligence is blah, blah thing. Explain AI, blah, blah thing. What does AI mean? These are the things. What are types of AI? This is the answer. Can you tell me about AI types? This is the answer. What kind of AI exists? This is the answer. Similarly, application. What are the applications of AI? This one. How is AI used? This answer. Can you provide example of AI application? This one. So who are some notable figures in AI? Tell me about famous people in AI. Who are the leading researchers in AI? These are general questions a person can ask about AI. I define the question versus answer. Then the default, I am not sure how to answer that. Could you please ask something about AI? This is the default. So then this is the rule I have defined now. Definition, what is AI? Hi, you go to the definition, right? Types, categories, kind. If you find the keywords in the customer query, go to the types and pull out one answer and display. If you find out application, buses, what can AI do, something kind of thing, you put it to application. Famous, notable, figures, people, put it to the figures and get an answer and put it over there. Category default, if nothing else is there, go to the default. So this is how I define the rule for the keyword search button. So then after that, I define the chatbot thing. Let's play it and chat it out. So hi, I'm AI information robot type. Hi there. So what do you think now it's going to do? I'm not sure how to answer that. Could you ask something else about AI? Why? Because I didn't define the hi there over there. Greeting is not defined over there, right? So that is gone. I'm going to ask what is meant by AI. So now, what is artificial intelligence? Right? It's what AI, it's these two are they are the keywords. It's find out and go to the definition. What is artificial intelligence? And it's pulling out the answer with the question over here. Clear? Right. So we will ask the same question again because it's going to do that thing. What is meant by AI? What does AI mean? That is the second thing that we have defined over here. What is AI mean? So these are different way of asking question. It is pulling it out and giving it to me randomly, right? So this is how. So now I'm going to ask, who are the famous people in AI? Okay, who are the famous people in AI, right? Okay. So it's a what does again what happened? Famous people it didn't detect, but what AI, who, something. Then what does AI mean? Again, it's pulling it out, right? Because of this thing. We'll go back here. Famous people in AI. Maybe say famous people. Just type famous. What is going to happen? It's going to say who are some notable figures in AI. Because what happened? I have defined the famous word over here as a keyword search and routing it to the category of figures. Under that figures, I have these three question design. So I pull out one thing and displaying it to you. So that's what these keyword-based chatbots do. But the thing is, it won't do any hallucination or it won't do any mistakes. If you ask something else, finally it's going to say, I don't know how to answer this thing because it's go to the default. If you find out some keywords over there, it's going to give you the answer, which is a predefined answer. Therefore, the brand will not be damaged at all. You get it, right? What is going to happen? So therefore, no need to worry about this stuff. So this is the issue. But I'm going to show you who are the legends. Who are the legends in AI? So what are the answer? Again, going to what is artificial intelligence because AI word is there in the first definition part, right? I'm going to type legends. Okay. I'm not sure how to answer that. So this is the issue in this keyword-based advert, right? So it cannot understand the legends and the famous are kind of similar thing we are looking for, right? I'm asking who is the legend in AI, who is the famous people in AI. So famous and legend are more or less similar approach in this context. But the keyword doesn't, based chatbot doesn't understand that concept. So how we can overcome this? How we can overcome these issues? So keyword chatbot is not going to work. Certain cases it might work earlier days, but nowadays it's not going to work because it's not performing well. So let's go to second option call. We will exit now from the chat. Okay, I'm exiting. So then the goodbye, done. So you understood the issue of the keyword-based search chatbots, right? Right. So what is the second one that we can do? So legend and famous are kind of similar, right? kind of same semantic meaning. So there is something called in the natural language processing semantic search. Semantic search. That means it's not going to look for the keyword. It's going to look for the meaning. It's going to look for the meaning. For the meaning, we can't just only use the tokens because token only differentiate the words. Take the words and arrange it in a tuple. But to understand the meaning of the word, you should have a certain numbering system where the meaning is added into that vector, embeddings, right? So the bird has the meaning vector. So that means we are going to use a semantic search next. So I'm going to go here, open up the next tutorial session, semantic search. Okay. Dialogues with AI. Right. Under that, semantic search, another thing. So now we call it as embeddings or we call it as vectorization. Both are same. Providing embeddings and vectorization of the text are same. So first thing what we are going to do is we have to tokenize the words. Definitely when we are adding this chat into this thing. After that, we are going to transform the input into numbers. That is embedding, giving embeddings. And similar concept have similar values. Right? After that, indexing means save the vectors and store contains with the vectors. We call it as vector store. And finally, find the similar vectors with cosine similarity. Add rule-based filters using content. So that's all. So now we are going to build a chatbot we are going to build a semantic search algorithm now. After that, we are going to use the semantic search to build up a chatbot and see how that chatbot performs, right? So this is the basic of the chatbot, the ease of chatbot that we have built up or the AI chatbot that we have built up, right? Semantic search. And there are two words to remember. One is semantic search, other one is cosine similarity. Cosine similarity. This is most popular one these days. It find out the semantic meaning in a very nice manner. Okay. So we are going to experiment those stuff. So for example, how the semantic meaning is done is, so let's say happiness versus taste. So give a kid cake, chocolate, and a broccoli and ask the kid to put it over here in a chart like that. It will say taste and happiness of this chocolate in cake is higher where the broccoli is lower, right? It has this one. So later on, the kid is given a spinach to eat and it's identify it's similar to this one and put it as a cluster, right? So in that case, what is happening now? Cake, chocolate, sweets, blah, blah, things are one cluster which has the same type of semantic meaning, right? Broccoli, spinach, blah, 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 blah stuff belongs to one category, which are less taste happiness. So which have a kind of same semantic meaning. So similar to that, we are going to break down the words, right? Break down the words and give a certain semantic numbering format for them. So based on that numbering, we are going to do the search. So we can see the keyword search versus semantic search. At first, search engines were lexical. The search engine looked for literal machines of the query words without understanding of the query meaning and only returning links that contain the exact query by keywords. By using regular keyword search, a document either contains the given word or not. There is not in the middle ground. But on the other hand, semantic search can simplify query building because it is supported by automated natural language processing programs using latent semantic indexing, a concept that search engines use to discover how a keyword and the content work together to mean the same thing, right? So nowadays, the Google uses that thing, semantic search, NLP, right? Algorithm. Earlier days, when they have released keyword search. Later on, they shifted after the NLP thing. So now we are going to learn about uploading a PDF, right? And asking certain questions to the PDF, right? So how we do it? First, we have to install certain dependencies. One thing is PyMU PDF. This is to handle PDF in Python. So if you are dealing with Python files, PyMU PDF should be installed because that is the library is used to work with Python. Transformers, sentence transformers. So these are two libraries or the one library which is going to use to vectorize our text in the PDF, right? Vectorize the text in the PDF. So we are installing all these libraries. Let's install it right now. So we have learned up to now the keyword search, how it works. And we have seen the keyword based chatbots are not going to be helpful nowadays, right? Earlier days, it helped for a while because they have defined all these for potential question and answers. Later on, you pull out and display. So you can ask me why I didn't use any training for these things. Training a sentence transformer is not a good idea because it's already trained, right? So you can use the existing thing. If you want to train your own thing, I don't think it's necessary because this sentence transformer is trained to transform the word into a vector with the semantic meaning, right? So most of the time I uses this. I never trained a new one. Spacey, I have trained one because it's not trained well enough to categorize Sri Lankan names, Sri Lankan stuff. So, but the sentence transformer is really good to vectorize the word in English and adding a semantic meaning over there. So now we have installed those stuff. Second, let's install upload a PDF and extract the text from the PDF, right? So here, this is a function to extract the text using the PyMU PDF. So I'm going to upload a PDF here. So choose files. I'm going to go. You can upload whatever you want. I have certain PDFs here. Let me okay, I'm going to install this one. US government something, right? It's a PDF over here. I can open it and show. This is the PDF that I have downloaded. You can add any PDF that you want, right? Upload the PDF. So on to April 2023, the US National Cancer Institute, blah, blah, blah thing. It's related to the cancer, okay? It's related to the, okay? This is the thing, the news article about this thing. So let's go back. So to our AII, is that okay? So now I have added the PDF. I hope you also added some PDF from your thing. It can be any PDF, doesn't matter. So now what we are going to do is we are going to chunk it. Chunk mean the PDF have lot of text. So we are going to say the chunk size 1000. So we are going to divide this PDF text into chunks. Chunks, small chunks, right? So chunk size over here is 1000 letters. 1000 letters, basically it means that. Then after that, this is the function which is going to return the chunks. So from the PDF text, I'm going to define this function right now to define the chunk. So in the sentence transformer, I'm going to load this model, which is actually to encode the chunks. So first I extract the text, and what I'm going to do, I'm going to divide that text into small chunks. So there are thousands of paragraphs, 1000 words, one chunk, 1000 words, second chunk. Okay. Another 1000 words, 1000 letters, third chunk, like that. Chunk by chunk, I'm going to separate. After chunking it up, I'm going to send the chunks through the model embeddings to give a certain number or embeddings to that chunks, right? Okay. Chunks words. So now I'm going to encoding the chunks, right? Okay, now I'm encoding the chunks and everything. Finally, did I run it? Okay, yeah. So it's extracting the it's doing the vectorization or embeddings part for the chunks extracted from the PDF. Okay. Now it's download the model, and we are using this all mini LM LSV2. It's a predefined model for sentence from the sentence transformer, and we are using that to convert into chunks. Now we have defined that one. Now we will do the semantic search. So what is going to happen is now, so this is a cancer. I'm going to ask, what is this document about? What is this document about? Right? This is the question that I'm going to ask from the PDF. Then what is going to happen is when you run it, relevant chunk just need to be offered participation, monitoring cancer data, infrastructure, underlines all of the plans, blah, blah, blah thing. So this is the chunk. US President Biden administration has proposed 2.7 billion in new funding implementation, blah, blah. The US government releases national cancer plan, blah, blah, blah thing. So this is the thing. The score of this chunk is 0.1849. So what happened is, I asked, what is this document about? Right? So it's converted into embeddings, chunks, and give a semantic thing. And it goes through the semantic embeddings for each chunk. And it's find out the chunk which matches with the question embeddings, and it's pull out the chunks and display it over here. So I'm going to increase the chunk size over here, right? Let's say increase the chunk size to maybe 10,000 or maybe 3,000. Okay, 3,000 or maybe 5,000. Okay. So now what is going to happen is the uploaded PDF is going to be 5,000 word as one chunk. So another 5,000 letters as another chunk. Another 5,000 as another chunk. Like that, it's going to separate the chunks, right? Then I'm going to do the embedding. So the chunks have a lot of words. So it's tokenized. For each word, it's going to give a semantic meaning, right? And after that, I'm going to do the same search. So now you can see the answer, it is increased. It is increased. See, this is one chunk, and because I have increased the chunk size to 5,000, right? So it's just getting that information and displaying it to me. So this is what happened in the chunk size. So now I'm going to explain what is happening in our chatbots, right? The ease of chatbot or something. So first, we do the same thing, the semantic. We have uploaded the PDF data, which has all the information about the website of ESOP. All the information, right? With the links, we scrape the whole data, gave it as a PDF, right? It's a maybe 200, 300 page PDF. And we define the chunk size as 1,000 or 1,000 to 5,000. Whatever the chunk size you would like to take, you can take, right? Maybe if the paragraphs are very small, detailed, you can go for a small chunk or a larger chunk. So what we do is we divide it into chunks and we give an embedding using a sentence of chunk has a word separated into tokens, and each word is given a chunk embeddings, right? And this chunk have a certain embeddings, right? So like that, multiple chunks are there in the piece, divided based on the chunks. So now I am asked a question. So what happens is, when I ask a question, what is meant by optimization function, right? The typical example that we use. It goes through the whole chunks, right? Because my question have an optimization word meant by optimization. So that means that question is first vectorized into these embeddings, and it goes through the PDF and identify what are the chunks have most matches according to this semantic embedding. And it find out first three. So here you can see the score at the bottom, right? You can see the score at the bottom. This score is actually 0.15, very small matching with the question, right? Very small matching with the question. So what will happen? It will select three chunks, first three chunks, or you can define first 5 chunks, right? Which matches much more semantic meaning with my question. Then selects these 5 chunks with my question, and it sends that chunks, 5 chunks with my question to the GPT, right? Now the GPT is smart. So it can understand the question because it has an attention layer, and it knows from the chunks, does this chunk make any sense? What is the meaning? What is the document about? But it's printed something which is not the answer, right? But if I put this one into the ChatGPT will rephrase that chunk and give the answer. I'll show you how it's going to do. So what is this document about? This is the question. Okay, what is this document about is the question. And this is the chunk that I got. That this is the chunk which I got. So I'm going to go copy this one. Okay, relevant chunk. I'm going to go here, copy this whole chunk, published in this thing. Okay. Then I copy this one. Okay. And the question is, what is this document about? Going to Chat GPT. I'm going to say new chat. What is this document about? And I enter this whole chunk. The answer you will get in the chatbot. The document is a news article from the Latin Oncology published in May 2023. It discussed the related news. See, this is what happening in your chatbot. It's not a big rocket science. So you detect the semantic meaning of the question and give the embeddings right to the question. That embeddings is going to go through the embeddings in your text, identify the particular chunk where that embedding matches the most, then get that chunk 1, 2, 3, 4, 5. Best 5 matches or 3 matches or 2 matches. Then what you are going to do is you are going to send it to the ChatGPT with the question. What I have done right now through an API. Then ChatGPT give this answer to me back. Right? Give this answer to me back. So let's reduce the chunk size again. Right? Go back. You go and reduce the chunk size again, maybe to 500. Right? 500. And I'm going to run this one. Earlier 1000. Now I reduced it further. Run this one. The same question I am going to ask. What is this document about? So this is the small chunk I got. Right? The matching is 0.23, but the matching is higher. Right? The chunk, because it has the embedding numbers. With my question, it's matching now. So I'm going to just go like this, copy this chunk over there and use this thing, copy and paste in a new chat. What is this? What is this document about? Document appears to be a new article, latent, blah, blah thing. This is the answer. See this answer? This is very detailed because the chunk size is larger. This answer, this is very small because the chunk size is small. You are getting it, right? So depends on the chunk size and the question, we are going to extract the sentiment, send it to the GPT, get this answer, display it to you in the front end. That is what happening in the chatbot. You are going to build a chatbot, right? So you can use these semantic searches over there. Now the question. Yeah, we'll go to that thing again. Yeah, okay. I'll come back to that question. So this is the thing. So now I'm going to ask again, go back and I'm going to increase the chunk size to a little. 1000 is a reasonable chunk size we use, right? Reasonable. The chunk size you can increase to a bigger because larger context you give to as an answer to the GPT. GPT is going to give a very concise, clear answer. But the problem now I'm using a free version. But if you are using with the backend, you cannot use a free version. You have to have an API. APIs are charged based on the number of words. So if you send a huge chunk for one question, the input number of tokens are going to be higher. 750 words are equal to 1000 tokens in GPT, in anywhere, right? 750 words are equal to 1000 tokens, right? If you are giving 750 words as an input, the words, not letters. Here chunk size is letters, okay? So if you are giving 750 words, then 1000 tokens are used. Then you have to pay for the token charges and it's going to reply the answer, which is also going to be huge. So the output token, let's say it's returning back 10,000 words, like 2000 words as an answer, then that's a big chunk again. That's a token. So input token, output token. So the charges are made based on input token and output token. So you are going to get a huge bill at the bottom, at the end. Answers will be crystal clear, but the problem is you are going to get a huge bill. So nobody will like it, right? So what we need to do is we need to reduce the chunk size and the answer will be shorter. You have seen for the bigger chunk size, bigger answer, smaller chunk size, smaller answer. So we have reduced the thing. If you ask any chat in this thing, there are small answers. So the chunk size is reduced now. Cool. So then I'll just done and I'm going there and sentence and I'm going to ask about the cancer. Let's open up the document. And where's the document? Here, you can ask certain question in your thing, whatever the document you ask. So I'm going to ask anything. somewhere, anything. Okay, there is a name, Lisa Lacasse, something like that. Lisa Lacasse. So I'm going to ask the chatbot, this not the chatbot, this empty man, what does this person said? This is the question, right? There is something she has said on the thing. Now I print it out. So what is going to happen is, this is the chunk. It gave me the answer for me. I'm going to copy. Okay, copy, right? Go to ChatGPT and I'm going to ask, what does Lisa, what's her name? Lisa Lacasse, Lacasse, Lacasse said. This is the question, and this is the relevant chunk. I got it from the PDF. Now the answer the chatbot is going to give me, Lisa from the American Cancer Society Cancer Action Network praised the plan's comprehensive framework. She emphasized that its detailed breakdown into key execution areas crucial for making significant impact on cancer prevention care. Lacasse highlighted that the plan focused on the entire cancer continuum. This is the chunk I got. So the chunk I got is here. We are excited about the comprehensiveness, Lisa said. So say, see, said Lisa. So if you open up the thing, this thing is got as the chunk, and it's not only that, it got something else as well. We go to this place, it's got that part. Lisa said after that, the American Cancer, blah 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 things. Also, the rest of the thing is got. So now what is happening? It is getting all these things and displaying it to us as Lisa said, but actually Lisa didn't say that stuff. What did she say? We are excited about the comprehensiveness of the plan's framework, said Lisa Case. That's all she said, right? That's all she said. But due to this chunk issue, size, this also went there. This also went there. All these things. So what the ChatGPT is giving me the answer. Lisa from American praised the plan's comprehensive framework. She emphasized this detailed breakdown into key. She didn't tell these stuff at all, right? So this how the misconceptions happen. But the answer is something good, right? It's good. It's detailed, but not exactly 100% correct. I want that phrase that she said, but it's giving the total thing. Now let's go and reduce the chunk size over here. Maybe to, and find out 0.23. So I'm going to reduce the chunk size to maybe 200. Let's say 200. 200, play, and play, and play. So this is the thing. See the score, 0.322. That means the score is increasing. So now I'm going to copy the thing, right? And go to ChatGPT and ask the same question. What does Lisa say? Now it cannot be done because this ChatGPT has a memory. So we have to open a new chat. It will give the last answer also. Now it says, see, Lisa from the American Cancer Society Cancer Action Network praise the plans framework, praise the plans detail, something like that, right? So this is how you upload a PDF and ask questions. So I didn't connect it to the GPT, but only thing I need to connect it to the GPT through API. So these chunks will be sent to the GPT, and the GPT answer will be displayed on your front end. This is what we are doing as a chatbot. Now you understood how the chatbots are working, right? So you extract all the information. First you vectorize it. So that is the vectorized chunks data. So when you ask a question, that question semantically embedded, and that embedding go through each embedding chunks, and whichever the matches high, it will select 1 chunk, 2 chunk, 3 chunk, 4 chunk, 5 chunk. You can even 10 chunks. But increase the number of chunks, what is going to happen? Finally end up in higher bill for the GPT, right? You have to pay for the tokens when you are using API. Then usually we use 3 chunks, best matches, and it identify the semantic chunks. pull out those chunks along with the question, send it to the GPT as I said. GPT responds back and you copy that answer and you put it over there. GPT function is in a transformer architecture. That is completely different, right? Before going to the GPT, we just do. So now the issue, what is happening? You are sending all the sensitive information data. So if you add a spacey, named entity recognition and the masker, it will change all these things and put it to the GPT, right? So we have built, I told you I have built a chatbot to detect the places and everything for the use case of a airline. So we build a front end like GPT and gave it to these testers. And the testers ask a question, what is the capital of Sri Lanka? The answer was, the capital of Sri Lanka is Sri Lanka city. For that NER direction, what happened? It's must. What is the capital of country? That's the question that GPT got, right? Because I'm asking, what is the capital of Sri Lanka? If I ask this one, okay, what is the capital of Sri Lanka? Sri Jayawardenepura Kotte. Fine, right? If I ask, what is the capital of country? This is what the mask information is going to see, right? It is asking about that. Could you please specify, because it's a chat bot. But what the API will do is, the capital of, the answer will be the capital of country is country countries is capital city. This is the answer the GPT gave. So when I came to the first thing, it will replace the country with Sri Lanka. Ne? So the answer the customer sees, the capital of Sri Lanka is Sri Lanka's capital city. So there are issues, right? So we have limited the access, saying you can't ask general questions on this chatbot. It is specifically made for using the client data and everything. So otherwise, the GPT will be uh, confused, right? So now you can ask a general question. Earlier it gave Javatanapura code, but this question it cannot answer. But if you send it to the API, it will answer as this country's capital city. So that's what they got. So there are certain issues that we have figured out during that session. So now the semantic search is clear, right? What is happening, right? It gets a chunk and you can even display the chunks over here as this one. So this is the chunk which is extracted from that semantic search, whichever the matches scale is 3.0.3225, right? So now when the chatbot is designed, the chunk size is important, and what type of this sentence transformation that you are using to do the semantic search. It can be BERT, it can be sentence transformer, old mini LM, L6V2, whatever. There are thousands of these sentence transformer models are there. So you can use whatever you want, right? Which uses different semantic embedding systems, right? LangChain have a one, GPT have a one. So you can use whatever you want. We will use couple of things to build up the whole chatbot. After that, you will be able to go and build a chatbot for your office or your home or whatever, right? So that is simple. It's not a rocket science. Whoever don't know this stuff, they think this big thing is happening AI backend, but this is the small thing happening in the backend, right? So now you will have the confidence. So now the semantic search is done. So now, yeah. Yeah. Yes. Yes. So what we need to do is if the website is updated, so we have automatically done the web scraping. So when you click update, what it will do is it will go through the website, pull out all the contents from the website, save it as a text. Then that text will be converted into a PDF. Then that PDF will be going automatically to this thing. It's fully automated. So they just need to update button, click the update button, go through the web, identify the context, put it into the PDF and do that. That's how we have to update. So new information comes. Other than, or else you cannot. So now it's a vector store, which has chunks and the embeddings, right? So best embeddings, 5 numbers or 6 numbers that you get, pull it out, put it over there, done. Right? Clear. Okay. So we'll learn about the how we can make it concise. Ease of chatbot sometimes give wrong answers. Wrong answer means it says I couldn't find the information here, but the information is there in the website. So there are certain issues because now it's a 1-page document I have updated. Imagine you have 200, 300 page document. Within a couple of minutes, it need to go and find out the similarity, get the chunk, put it there, get it back. It misses certain information, right? So this is a search called cosine search. If you find out over here, uh, here we use utils, PyTorch, cossim. This is called cosine similarity search, which do the question embeddings and search through the chunk embeddings, right? It's a different mechanism. Similar to cosine similarity search, there are other similarity search also available. But out of that, cosine similarity search outperform everything when it's come to chatbot scenario, right? So we are using the cosine similarity search implemented by LangChain. LangChain is another library providers. So we are using that to do that. So now we know how the real chatbot is working. So without sending to the GPT, right? How we can make a semantic based chatbot. So that's what we are going to learn next. Go to here, go down, semantic search based chatbot. So now the chatbot is not only going to use the keyword search as we have done earlier. We have seen how bad it is. We are going to use the meaning of the word. So if I say the legend and the famous or ideal person or something, those are in the same category semantic. So it will be able to find out now the same chat and answer me. So let's see. We are going to install the dependencies. So in the manage session, you have to cancel the others and play it out. Sentence transformer, the transformer model. It was little down, I think. eSoft. Let me open it up again. Okay, now it's done. Earlier it was slower, now it's faster. See, what is meant, what courses, what HND courses you have, HND. Let's see the answer now. See, now the answer is there. What happened? It was disconnected from the vector database earlier. So I just sent a message a bit. Now they said they have upgraded. Right? So I checked it and this guy, see, please check eSoft Chatter. It's down, seems like. Please fix it quickly. So done, sir. Can you check? So done. Now the answer is different. Earlier it says I didn't find the information because the database vector is disconnected. So when you ask the question, it embedded and it looked for the database. There is no database. So it goes to the default answer and put it over there. Right? Same approach. So say default answer and put it over there. I couldn't find the thing. Go to the eSoft chatbot. But now the eSoft Metro Compass of following HND courses, person, see the answers. Now it's connected to the vector database, right? So now we are going to build up this semantic search based thing. I have installed the dependencies. Then I'm going to import the libraries, sentence transformer, and NumPy as NP. That's basically we need to install all this stuff. So once it's done, I'm going to use this transformer. It's a mini one. But if is it going to be a very complex context, it's a literature, English literature story, the meanings are not directly embedded. So you have to have a different type of meaning. So when you are going a mini max LM, mini medium max LM, so that is going to be trained in a certain ways with much number of large data. So it will be able to identify the semantic. So I'm going to load the model, this one, sentence transformer, this one. Let it load and install all the stuff. Once it's done, we are going to define the data. Earlier, we defined the rules. Now we are going to define it as a data definition. What is artificial intelligence? Blah, blah thing. Explain AI, the same thing that they have defined for the keyword-based chatbot, right? I'm going to define the data. So earlier, what we have done was done the thing. Here I am question pairs, flattening the data for essay processing, easy processing, because I need to give a embedding score. So I am using this sentence transformer to completely giving a vector number embeddings over here, right? Now that is given an embedding and it's saved at an embedding thing. Now we are going to do the chat, right? So I'm defining the chat. Let's chat with it right now, right? So this thing, I am the same way. So now I'm going to ask, what is AI? So now you can see it gives AI stand for artificial intelligence, which is the capability of machine learning. The same thing question I am going to ask here. What is AI? Same answer is given over here. Give me a second. Where are the rules that I have defined? Flattening the data. There is no such rules I define. Look for the keywords because I am not looking for the keywords. I am looking for the semantic meaning, not the keyword search. Earlier, what we have done? We have defined the keyword searching strategy. Here, I am not using any keyword searching strategy. I am embedding into the semantic search and searching the best match based on the cosine score through the thing, because I'm using a cosine similarity search. You don't want to know what is happening in the backend. I also don't know what is happening in the backend. I use this library, right? If I want, it's complete mathematics, right? So it will take, I don't know, to understand for me. Even I'm trying to learn this transformer fully because I need to teach you. So still I'm struggling to understand to get it as a practical approach. So these things I have used it, so I know. Transformer things I will explain you sooner. Okay. I didn't get time last week to spend some time. So, but I will explain you. I have used it, but how to easily explain you, I still don't know. But I can write the equation and show matrix way, right? Still I can do that now, but you will not understand. So that's the thing, it take time, but before this 14th week, we will be able to do that. So now you can see what is AI? What is meant by AI? I'm going to ask another question. What is meant by AI? AI stands for artificial. The same question is given. Okay. So we will ask who are the famous people? Famous people in AI include Andrew, blah, blah, blah things. It's gave. Last time also it gave for the keyword set. But who are the legends in AI? Last time it didn't give. The keyword search didn't give the answer for that. It say, I don't know how to answer this. Ask me something else, Kela. Right? So now it is giving notable figures in AI include Alan, blah, 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 blah thing. See, the answer is given. Why is that? Because we are not looking for the keyword. We are looking for the semantic meaning. It knows legends and the famous people are more or less same meaning, right? So it's pull out the answer from the data. Tell me about the famous people who are the leading researchers. So notable figures, who are notable figures and legends are the same meaning. So it find out this is the best answer for the meaning, it displaying it. So that's how the Taj Hotel bots works right now, right? fully on the semantic based search. We'll go to the Taj Hotel. We go there. There is a chatbot pops up. I don't know whether they have updated to GPT based chatbot or not, but earlier they have used the semantic based chatbot. Let's wait. Yeah, here we go. Okay. Non-member. Okay. Before you press it, can you share your mobile number? 070-5997-63. These can be done because of the first welcome messages. You can enter them. Now it's saved. The mobile number that you have entered is valid. What is that? Okay. +9470-597-6364. See, this is the problem. I entered a valid number, but it's invalid. So it's a semantic search. That's fine. I need to know any offers. 070-597-6364. Maybe it is correct. This is the problem with these chatbots, right? It gave a thing. They have given a number 070-597-6364. Maybe this one. Wait, giving some hard time to me, right? So this is the, if you start to chat with this correctly entered, you can see the semantic waste of chatbot. Go home and try it out. It's not working for me now. So again, any other meaning of legends? We'll go to Chat GPT. See no pro legends. They will take something. Notable celebrities. Okay, I'm going to ask celebrities in my chatbot. Who are the celebrities? Who are the celebrities? Okay. So the thing is, in the data, I never used a word called celebrities. Right? Let's see what is giving. Famous people in AI. See, that's the beauty of semantic search. It knows celebrities, legends, famous people, notable figures are belong to same category of these things. And it goes through these embeddings, find out the semantic meaning of that thing is matches with this thing, pull out the answer, display it to you. Clear, right? So in that way, you can build up an advanced version of the keyword-based search chatbot, but still you have to define the question and the answer. But in the GPT-based chatbot, you don't do that. Because it go through, select the chunk, send it to the GPT. GPT understand the context because it has the attention layer, get the answer, display to you, right? But these semantic-based chatbots are very solid. If you know what your customer is going to ask, this is very solid, right? Because it find out the answer, display the exact answer what the customer wants or what you want the customer to need. Look at. But this one, ease of based chatbot, it's not like that. I'm going to ask the same question. Same question. Let's see the answer. At Ease of Metro Campus, we offer the following HND courses is the answer over here. Second time, we offer a variety of HND courses at Ease of Management. Completely different answer, but it gives us insight what it needed to be. If you ask it again, it is going to give a different answer because the ChatGPT is going to think, I gave an answer, he didn't understand. Again, he's asking the same question. Let me rephrase the answer in a different way, give an answer. Because it's called a temperature setting. There is something called temperature setting. How variable answers that the AI gives. I'll show the temperature setting. We'll go into detail. This is a different one. Okay. Let's see. I'll show one example. Right. So here, retrieval question and answer. So I have a, legal document, default document uploaded. It talks about the laws and everything about the migration of a student. So retrieve means it's going to get the chunks. I'm going to ask, what is the minimum IELTS score for a student to get enter to UK universities? This is the question I'm asking. What is happening now? I am entering it, submitting it. What's happening is it's going through the PDF that they have uploaded, find out the similar answers, semantic matches, and it's going to get the chunks over here. So this is the chunk that I got. From that search, one chunk, two chunk, three, four, totally five chunks I'm sending, right? And the answer that I'm getting is this one. The minimum IELTS score for a university is reworded answer from the ChatGPT. So I can change this. So I can say search correct number 5. I'll like limit to 2. Okay. Okay. Submit. So something called temperature. I'm going to come to that part. Temperature means, okay, 1. So again, 5 chunks. It's a correct number is a different thing for the semantic set. We'll come change type, that different similarity. Okay, cosine similarity. So these are the prompts. So let's reduce the thing to 1. Okay. I'm going to submit it again. I'm going to show you the difference. Okay. The same question I'm using. So it goes through the PDF, get the change. So if you said 1, it's going to give a maximum varieties of answers. So now I'm going to say submit. According to the provider sources, the minimum, check the answer, right? This is different. So again, I am submitting again. Yes. Now the answer is completely different, but the same thing, context is there. But the way it's answered, the GPT answers is different, right? So other thing, third time I'm going to try. Let's see how the answer is coming. According to the prime page 49, something similar. But if it's 0, submit. I'm going to submit it again. According to the provided sources, the minimum IELTS score for the student to enter UK universities depends on. Okay. Again, I'm submitting. It should have very less number of varieties answers. So what this temperature is, according to the providers, the same answer is given to me. If I submit it again, again the same answer will be given to me. Why? The GPT is temperature setting is set as 0 now. 1 means maximum. See, but earlier when it's 1, it's give different answers. 0, it's giving the same answers, right? Again, you see that, right? Same answers. What is happening? The temperature setting is, so I said, I can jump over, this is the sentence, can jump over, then you say complete the sentence with one word. That is the prompt that you are going to enter. So the ChatGPT will be cat jump over the fence. Maybe if you ask the same question, it will give cat jumped over the table. Fourth question, it will give cat jumped over the something chair. It's giving different words. How the ChatGPT works basically? Identify the most common word which is used after the previous word. So when it's come to the cat jump over, it knows the context. Over means it knows should come next. That is the most commonly used word in the text that it's trained for. So it put that there, then it will say table, chair, this. There are over the table, over the wall, over the fence, over the moon. There are a lot of things there in the text. It's trained for billions of data. So now if you set the temperature to 0, it cannot select multiple words. It will find out what is the most used word in the text is trained for. It's going to print the same word again and again. Maximum probability. Right? Therefore, the variety answer will not be there. So, because maximum used words, let's say the first 10 words, wall, moon, table, chair, everything. So they have set the temperature to 0.5 to give select different words. First time table, second time this. That's why you are getting different answer, rewording in different manners. That is called temperature setting, right? So we will learn that is coming to LLM next time. For example, I'll go back to the GPT. I'm going to show you this one. Give me a second. ChatGPT. This is a ChatGPT. This. Complete the sentence. Cat jumped over. Okay. Cat jumped over the fence. Again, I am asking this one because fence is the most common word. The moon. Again. The lazy dog. Again. The pile of autumn leaves. Again. The same question, it giving different answers, right? Because the temperature setting is not 0. Now I am going to go set the temperature settings to 0. I'm not sure. Let's see. No, it's not getting it. So you cannot set it manually like that by a prompt, I believe. But if you set it in the backend, it's going to give the same answer again and again because there is no variance. It will select the maximum probability word it have been used after that, right? So that thing will be gone. So you can see this is the temperature setting. So when you enter the sentence, it select what are the words used, pile of words used after that over the, then it select one out of that, randomly select one out of that. So that is the how randomness that you want is the temperature setting. You have seen with the 0, it's giving the same answer again and again and again. But when you put it to 1 or 0.5, whatever the things, it has the different answering way. So that is the temperature setting. So that we can play with that. Okay, the minimum IELTS score, see the answer is completely changed because the temperature setting is high. You are getting it, right? What is the temperature? So now today's lectures, we have learned about how to build a rule-based chatbot using keyword search. A rule-based chatbot means we have defined the question and answer. And using the semantic search, how we have built up the chatbot. Again, it's a rule based because you have given the question and answer already, right? So now this is done. So now we are going to go for next class, how to integrate this in kind of chatbot to the GPT, right? Using an API key, right? Week after next, we are going to talk about something, the memory feature. Because now you are building a chatbot, right? The chat GPT remembers what you are talking. Even you ask some question again in the middle, it will be able to answer, pull out from the previous conversation, right? In the same chat history. But when you are using a PDF like that, chunks kind of stuff, it pull out the chunk, send it to the GPT and get it back. And the GPT session expires. That means it forgets. It doesn't keep the content. And if you ask a follow-up question, it doesn't know because the session expired. The follow-up question, it goes through the chunk again. It will give a totally different answer, right? So therefore, to keep the memory, we have to build up a RAG architecture. So that will be the 14th or 15th lectures. Okay. So we'll learn that. So this basic is clear, right? How the chatbot's evaluation came up. Keywords, semantic, and chunk selection. And we are going to learn about the GPT integration next class. Then after that, we are good to create a chatbot. Still not, because we need to learn about RAG architecture. That week after next, we are going to learn about RAG architecture. That's cool. Good. Okay, so there will be a seminar on August 11th or 12th, probably 12th. Professor Jason Mars is coming to Sri Lanka. Right, he'll be there in university. So if you guys are interested, you can come and join the seminar. It'll be good. He's a leading guy in AI. So super. He started to use these build up chatbots for a bank, build chatbots for a bank before this ChatGPT came up. So he's very good in this thing, Jason Mars. You can type Jason. This guy. Okay, he's a big shot. He's appointed as a honorary professor in our department as well. So you can just go and check his profile. He built up chatbots for Clink bank application. Won a lot of awards for that, and he's a tech talk. He's a very famous figure in here, right? So you can just go to his bio and check all this stuff. So he'll be here in August. So I will send the invite. So if you wish, you can come physically over there and attend to that. Okay. So very famous guy in AI stuff. So I'm collaborating with him. All right. So that's all for today's session. Any questions? No? All clear, right? How the chatbots are made? Have confident to build a chatbot? No? Okay, good. So then we'll meet next week and we'll discuss the GPT integration and enhance the PDF based chat or whatever the chatbot you want to build. You can build a chatbot in your office also. It's not a big deal at all nowadays, right? So earlier when this comes up, chatbot was a huge deal. Everyone was talking about chatbot. But nowadays, even a school kid can build a chatbot because the resources are there in online. But to know how the evaluation happened, you have to go through the theoretical stuff as well. So we will slowly touch that part as well in next lectures. And we will do that. All right. Until then, thank you. Bye.